All right.
We're here because we're here.
We're here because we're here. There you go. All right.
Yeah.
Nice. I'll go out
There you go, guys.
and name tag or something.
Say hi.
That's Greenville connection here today.
You're the program. Yeah, you're gonna be the program.
What you got going on here?
We got some model data over here. Got some observations over here. See radar over there. And here's satellite with some observations.
Oh, I see. On top of it, so you can
Yeah.
superimpose the two of them.
Mm-hmm.
Yeah. That's neat. That's
And
neat.
this is our morning sounding. So our morning weather balloon. Saw the
They
data.
still launch those.
Yep.
Huh. So now is the red path where the balloon went, or what's the red line?
The red line's temperature, the green line is dew point, and it's on like a tilt, so the temperature goes up like this.
Okay. Oh, I
So-
see. I see. So that's altitude.
Yeah, so altitude goes up, and
Okay.
then so the temperature was really cold at the surface, and then we had an inversion, so it warmed up to here, and then it was fairly consistent up to around like 600 millibars, and then it decreased
Wow. Okay.
a lot more.
And the green line was
Dew point.
dew point. Oh, okay.
So it's really
Interesting.
really dry down here
Uh huh.
in the lower atmosphere, but in the middle atmosphere it's a bit more moist.
Huh. Now that's just one probe going straight up, right?
Yeah.
I see. I see. So now, wouldn't that be nice to have three-dimensional data on that?
Okay.
And what's this one show you?
This is one of the computer models. This is the European model. So this is Saturday. This is today, and then we're looking at maybe some rain coming over Sunday night into Monday, and then again for Tuesday into Wednesday. Then it's gonna get pretty cold next weekend after we have a big cold front, and then you can see this is 850 millibar temperatures, so we're gonna get some like minus 12 850 millibar temperatures, which is gonna be highest temperatures in the 40s next weekend.
I'm from Michigan. That's not a problem.
Not a problem.
No, it's when it has a dash in front of it.
Yeah.
Yeah. The dash is the problem.
This is the interface with the Doppler radar, the big soccer ball out there on the tower. Right now it's in what we call the clear air mode because there's no weather going on out there. So it's doing 5 elevation scans in 10 minutes. Right now it's at 3.5 degrees, and that shows you how fast the dish is turning right there. See, it's on this little yellow line. And next it's going to go up and do 4.5 degrees. And then when that gets done, it goes back down to the bottom and starts all over again.
What's its range from?
About 240 nautical miles.
Okay. In terms of azimuth,
Oh,
Well, it's
it's a set azimuth.
No,
well,
you
these
see
are
the different elevations.
and then it's scanning around, and then it tilts up, and then it scans around.
Okay, so you got 3.5 degrees.
Right, and the next will be 4.5 degrees.
4.5.
Right. And then when it's done with that, it comes back down to the bottom and starts all over again.
Well,
So
what's
it's
the
constantly
bottom?
scanning the atmosphere.
Is the bottom 3.5?
The bottom is half degree.
Half, so it goes
0.5.
half to half.
Correct.
Okay.
To 4.5.
Now, if we were in severe weather mode or convective mode on thunderstorms, it's doing 14 scans in 5 minutes.
Okay.
And in case you're wondering what the transmitted power is, I can tell you that right quick. It's 635 kilowatts.
Just
Wow.
a little bit.
Yeah, don't get close to that.
Yeah. Yeah, if the ETs have to go up in the ball and work on it, of course, they have to turn it off.
Jeez.
It's a 33-foot parabolic dish inside that ball. The ball is just to protect it from
Right, from the weather.
This represents the the site outside, we call the radar data acquisition, basically the radar site.
Yeah, yeah.
This right here is the equipment in the next room, which we'll show you in just a couple minutes. And users' comms are these workstations out
Okay, okay.
So when you see the three parts that are connected by green is
They're
good.
communicating.
It means all the parts are talking to each other and data is flowing. This is our hotline to the National Hurricane Center down in Florida. Whenever there's any active tropical weather, every 6 hours they put out advisories, whether it's for a tropical storm or a hurricane. If it's going to affect land, and they could talk to a weather office whose area it's going to affect, like we talked to them during Hurricane Matthew over this right here. This connects to the different counties, National Advisory Warning System. A lot of times if somebody phones in a water spout report to Dare County will call us on this. Dare County, to National Weather Service Newport. We can talk to them on that. This is a national mosaic I've got up here. This system right here is the one that's going to be lifting east-northeast, and it's going to bring us rain from like Sunday night through about Tuesday, because it looks pretty wet. This is a visual satellite picture from the GOES satellite, about 22,000 miles out in space. I don't know whether you saw it in the news or not, but within the past week or so, they launched a brand new GOES satellite, GOES 16. It's going to have many more satellite channels, much faster frame rate. It'll have lightning monitoring equipment on it. It'll have all sorts of new stuff. And that will probably come online in the next 5 or 6 months. So it's exciting stuff. It'll have all sorts of bells and whistles on it. This is a computer model. You may have heard of the GFS, Global Forecasting System. This is one of the models that we use. This is a surface map, basically. And it goes out 10 days. And what you're looking at, there's the surface low and high. It's like the map that you would see on the Weather Channel or local TV news. The color that you see is humidity, relative humidity, from just off the ground to about 20,000 feet in the atmosphere. And it's shaded starting at 50% and going up. So when it goes from green all the way up to like
purple.
pink. Yeah. So that shows where there's a lot of deep moisture.
Yeah.
And of course where it's black and gray, that's where the atmosphere is very dry. So, and this is a forecast map for this afternoon. This goes in 6-hour increments. That's 18 Zulu. 21. Sorry, it goes in 3 hour. 0, 6, 3, 6, 9. It's 12 Zulu tomorrow morning. See the high is moving off. I go further out in time. And this is Tuesday morning. System here is lifting all that moisture up.
Looks like my buddy's going to get clobbered
Yeah.
up there in Michigan.
And we can look at things in look at computer model data in a 4-panel display. And these are little macros that we can create. You can put whatever forecast element you want in each of these, and you can manipulate the lines. You want them thicker or thinner, different colors. You want it dashed, or whatever. You can kind of tailor it to suit your needs. And the setup that I have here is this is the wind flow from about 14,000 feet to about 20,000 feet. This is that surface map that you saw. This is a forecast of precipitation, and this is called lifted index, which shows instability in the atmosphere.
So the bright green light top left, is that the jet stream?
What you're looking at here, you can see, I don't know if you probably can't see them, but if I can zoom in here, you see these little X's. That's a forecast element that's called vorticity. It's a measure of angular momentum around a point. So wherever you see these, That's where there's a little counterclockwise spin in the atmosphere.
At 14,000 feet.
Yeah, well, in that layer.
Uh-huh.
And the wind is basically following these lines.
Those
when I get up
isobars,
that high.
okay.
Well,
It's like eddy currents. Lucera sounds like it's like eddy currents.
they're wind. These are wind streamlines. Wind is flowing along these.
Yeah.
Generally, yeah.
Yeah. So basically, that's where there's a lot of spin in the atmosphere. That's
Is that where a thunderstorm or something might come up? Or
well, this would be an area of disturbed weather, especially if you put it along with an area of deep moisture. It's going to stir something up.
Yeah,
It shows
something's
it's
gonna
going to
come
be
out.
unstable. So there's all the rain.
Gotcha.
This is an interface that we put out 4 aviation forecasts for New Bern, Greenville, Albert J. Ellis, and Kinston. And it's called a TAF, Terminal Aerodrome Forecast. It's coded. It's only valid for 24 hours, and we issue them every 6 hours for wind direction and speed, cloud amount and height, any obstructions to visibility like fog, rain, snow, smoke. We also put in anything for low-level wind shear if we think there's going to be any. And this is just the interface for it. And this takes our coded forecast, compares it to the actual observation, and if everything is green, that means the forecast and the observations are matching up well. If it starts to go just a little bit off, it turns yellow, and then I believe after that it's like orange, and then red, and then purple. So we can send
Purple's
out
never a good color for
no.
No.
So we can always send out a real quick amendment to improve that.
Gotcha.
This is just a display of different conditions at airports around the area. EWN, New Bern, PGV, New Bern, OAJ is Albert J. Ellis, ISO is Kinston, and so forth. And that's just a regular PC. All that data that you saw on those AWIPs display comes down to a giant dish that's out there on the ground. And it comes into here and gets processed and then sent out there. This is also where the radar data comes in, the raw data, it comes in, it gets processed, gets colorized, and then sent out to the workstations. It's also where our HVAC is, and these, you've probably seen before, these are
tile. Yeah.
all the cables run underneath. This is where our 2 electronic technicians work. Like I said, they're just here Monday through Friday, regular business hours. And it's where all their manuals and tools and equipment and things are that we launch every day.
Oh, yeah.
There's the balloon right there.
Huh.
Right there. Take that outside and pull it up, and this is the
Parachute.
parachute that goes on.
Oh, that is so cute.
And the instrument itself comes in this package.
Like a chocolate bar.
Yeah.
Except a big.
It's about, I believe the base where the ball sits on, I believe that's 98 feet. Every few years the ball is actually cleaned. Got a guy up there, I guess the Weather Service contracts him out, and he's got some sort of cable attached to the top, and he's just
Bouncing
going
around.
bouncing around the outside, scrubbing that thing.
Pressure washer.
Yeah.
Couldn't pay me enough. Thank you very much.
Now,
We record 24-hour rainfall here with this gauge right here. Take that off.
Uh-huh.
That's what we use right there. Just stick it down in there. That dish over there, the big one, is the downlink for our AWIP system. Down.
What's over on that other building?
That over built? That is. Oh,
we don't.
soda bottles. Put it in a pail. So
Run off there's also power.